Good morning, students. Today we are discussing about the dimension analysis applied to the force convection heat transfer. Okay, let us start with some basic numerical that have. Let us consider uh, the heat transfer coefficient in a fully developed force convection in a tube is a function of following variables. And these variables are H, heat transfer coefficient, is a function of rho, it is the density, it is the diameter of the tube, V is the velocity, and mu is the viscosity, Cp is the specific heat, and K is the thermal conductivity. So, function F1 is is depending on a number of variables, and these numbers are 1, 2, 3, then 4, 5, 6, and 7. So we got n is equal to 7, and the dependent variables are here. We are used for the force conversion. That's why we are introduced one more dependent quantity, that is theta, and theta is denoted for the temperature difference. That's why we are using M, L, P, and theta. That means the value of M is equal to 4. So the number of pi units are n minus m, that is 7 minus 4, we got the 3. So so here the pi functions are pi 1, pi 2, and pi 3. Okay, you just remember the values of these points. Means for heat transfer coefficient mt minus 3, theta minus 1, rho is the density, means kg per meter is kg per meter cube, then d is the diameter, and d is the velocity, mu is the viscosity, specific heat, and thermal conductivity. Okay, so we choose H, rho, V, V as the core group repeating variables with unknown components. These groups and to be formed are now represented in the following five groups. So let us start. I1 is equal to H a raised to power 1, rho raised to power B1, B2 raised to power C1, V raised to power D1, and we add a new one is mu, and pi 2. Sorry, it is mu. Pi 2 is equal to H raised to power A2, rho raised to power B2, D raised to power C2, V raised to power D2, and Cp. Similarly, pi 3 is equal to H raised to power A3, rho raised to power B3, D raised to power C3, V raised to power D3, and K. Okay, so pi 1, we are getting the term pi 1. For pi 1, we have to use this equation. So pi is a unitless quantity. That's why we are writing m0 l0 t raised to power 0. H is the thermal conductivity. That's why we are using m t raised to power minus 3, theta raised to power minus 1, the whole a1. Then similarly, rho is putting here, d is putting here, d is putting here, and ultimately mu is putting here. And when we equating their powers, we get 0 is equal to a1 plus b1 plus 1. That means we get a1 plus b1 is equal to minus 1. Similarly, we are putting equating for the value of L and value of P. Ultimately, we get the value A1 is equal to 0. That means B1 is equal to minus 1, C1 is equal to minus 1, and D1 is equal to minus 1. This indicates that pi 1 is equal to rho raised to power minus 1, d raised to power minus 1, v raised to power minus 1 into, or we say that mu upon rho t into v. This is the pi 1. Similarly, we get the pi 2, the value of pi 2 when we equating this term here to here. And when we compare their powers, we get phi 2 is equal to h raised to power minus 1 into rho into v into c. That means phi 2 is equal to cp into rho into v upon h. Okay. And since dimensions of h and k upon d are the same, hence phi 2 is converted. That means if this h is converted into k upon d, so phi 2 is equal to cp into rho into vd upon k. Similarly, we get the value of phi 3 by equating the values. So we get after comparing their powers, we get the a3 is equal to minus 1, b3 is equal to 0, c3 is equal to minus 1, and d3 is equal to 0. That means phi 3 is equal to h raised to power minus 1 d raised to power minus 1 into k. So pi is equal to k upon hd. According to the phi theorem, phi 3 is equal to phi of phi 1 into phi 2. That means k upon hd is equal to c into mu upon rho raised to power and d into v raised to power m dash into cp rho into d into v upon k raised to power n dash. Okay. So let us consider here m dash and n dash is constant terms, and if we say m dash is greater than n dash, then the value is further converted into q upon hd is equal to c into mu upon tv raised to power. Here we are using the basic formula that m minus n plus n is equal to m. So we just use this equation to here. Okay. So mu upon rho into d into v raised to power n dash into this term, and then mu upon rho into d into v raised to power n dash m dash minus m dash. So when we comparing these two powers, then they both are come in contact with each other. Okay. So when they are come in contact with each other, they are just cancel out. So this will decrease my formula in a simpler way. So mu upon rho into d into v into c mu upon mu into cp upon k. So ultimately, this dash term is indicate the inverse. So let us denominator are changed in numerator and numerators are changed into denominator. So h2 upon k is equal to rho dv upon mu raised to power m, and remember this will cannot be changed now. So mu into cp upon k raised to power n. So ultimately this value, which is called Nusselt number ND, and rho dv upon mu is called Reynolds number, and mu cp upon k is the Prandtl number. So the conclusion is Reynolds Nusselt number is depending on the Reynolds number and the Prandtl number. So here C, M, and N are the constant and evaluated experimentally. So you have just to remember that when you are in this stage, you have to remember the values of Nusselt number, Reynolds number, and Prandtl number. Then after you will convert this whole equations. Okay. So you got the another number. This is called Staten number. So Staten number is the ratio of h upon rho into v into c. Okay, that means Staten number is a function of Reynolds number and Prandtl number also. So next topic is the dimensional analysis applied to natural or free convection heat transfer. Similarly, we have to take the case heat transfer coefficient H is a function of rho into L into mu into Cp into K into beta into G into delta T. Here, beta is the coefficient of volume expansion. Delta T is the difference of temperature between the heated surface and the distribution fluid, and G is the acceleration due to gravity. So For the for the simplify this whole equation, we just use these three terms in a common manner. So beta into g into delta t is considered as a one factor, physical factor. So in the parameter b into g into delta t represent the Bayes force and has the dimension of LT minus 2. So we again get 1, 2, 3, 4, 5, 6, and this is the 7. And number of sevens are 7, and n is the 4. So the number of pi units are 7 minus 4 is equal to 3. So the function is depending on pi 1, pi 2, and pi 3. So let's start. Pi 1 is equal to rho raised to power e1, L raised to power b1, mu raised to power c1, k raised to power d1 into h. Similarly for cp and for b into g into delta t. So when we put the dimension analysis here and when equating the powers of the values, so we get pi 1 is equal to L into k raised to power minus 1 into h. That means HL by k. Okay. Similarly, pi 2, when we equating the powers of the different quantities, we get a2 is equal to 0, b2 is equal to 0, c2 is equal to 1, and d2 is equal to minus 1. This means pi 2 is equal to mu into k raised to power minus 1 into cp, or pi 2 is equal to mu into cp upon k. Similarly, we get the value of pi 3, and the pi 3 value is rho square and mu raised to power minus 2 into beta into g into delta t. So pi 3 is equal to b into g into delta t into L cube upon v. Sorry, mu square. Okay. So this indicates that Nusselt number is a function of Prandtl number and Kirchhoff's number. And this C, N, and M can be found by experimentally. So the advantages and disadvantages of dimensionless analysis are: it expresses the functional relationship between the variables in the dimensionless terms. By the proper section of variables, the dimensionless parameters can be used to make certain logical deduction about the problems. And for design curve, by the use of dimension analysis can be developed from the experimental data or direct solution of the problem. It enables getting up a theoretical solution in the simplified dimensionless forms. Dimensionless analysis provide partial solution of a problem that are too complex to be dealt with mathematically. Dimensionless analysis is a useful tool in the dimensions analysis and correlation of experimental data, in the planning of experiment, and in the formation of empirical correlation describing a particular phenomenon. The result of one series of tests can be applied with the help of dimensionless analysis to a large number of other similar problems. But there should be a limitations. The first limitation is dimensional analysis does not give any clue regarding the selection of variables. If the variables are wrongly taken, the resultant functional relationship is erroneous, means a number of errors are found in your solution. So it provides the information about the grouping of variables in order to decide whether selected variables are pioneer to or superfluous. Experiments have to be performed. The complete information is not provided by dimensional analysis. It only indicates that there is some relationship between the parameters. It does not include the value of coefficient in the functional relationship. The value of coefficient and hence the nature of functional can be obtained only from experiments or from mathematical analysis. Third is no information is given about the internal mechanism of the physical phenomenon. And lastly, it is desire to find the effect of one physical quantity upon a number of other physical quantities that are supposed to enter into a problem. It is not possible to get such information with the help of dimensional analysis. So this is all about your dimensional analysis. The next time we have discussed about the dimensionless numbers and their physical significance. Thank you very much.